Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, hands of straights. So basically with this problem, we have Alice that she has a number of cards, and she wants to rearrange the cards into groups so that each group has a specific size, and we get that size in the input. And those, the numbers in each group need to be consecutive cards. Okay, so for example, it needs to be 1, after that 2 and 3, so consecutive. And we get a hand, and we need to rearrange it into groups of size, whatever we get here. So for example, here we get this hand, and we need to rearrange it into groups of size of 3. Okay, and the goal is to see if that's possible or not, because we have two constraints. Each group has to have exactly group size, and each group has to have only consecutive cards. So you can't have like 4 and then jump to 8 in the same group. Okay, so if we take a look at the first example, well, we can just put these two together. So we have a group of size 3, and they are consecutive. Then we put 2, 3, 4 together, consecutive again, and size 3. And then we put 6, 7, 8 together, and that's also consecutive and of size 3. So that works. However, for this example too, it doesn't work because group size is 4. So we do 1, 2, 3, 4, which is consecutive and of size 4. But then this 5 here is left without any group. So we return false. Okay. So we need to use the entire hand, and we need to have groups of size, the input group size, and we need them to be consecutive. Okay. So that's what we are dealing with. Now, let's think about a couple of things here. So if the first thing you should notice is that this duplicate here. So we could have duplicates in the same hand, and as a result here, we have 2 in one of the groups, and then we have the other group start with 2. So this tells you immediately you can't just start from 1 and do 2, 3, 4, keep basically incrementing, because one group can start with an earlier number than the end of the other group. Okay, so how do we do this? Well, the key thing to think about is, let's deal with this like buckets. So let's just have some sort of let's deal with this like if it was a bucket. So we know we need groups of size 3. So from this we can know how many groups we need, right? Because, for example, here, 3, 6, 7, 8, 9, we know we have 9 elements total. So how many groups we need? We know we need 3, because 3 multiplied by 3, that gives us a 9. So we know we need 3 groups. Then we can just go through the occurrences of elements and just add to these groups. What do I mean by that? So what we can do is, this format here is not very helpful, right? Because we want to know the occurrences of each number. So what we can do is convert it to sort of a map or a counter, where we know 1 occurs once, 2 occurs twice, right? This is more helpful because we can subtract as long as it's not 0. This is that there are 2 2s. It's easier to manipulate with this than with an array, right? And so that's why we do this. So we have 3, 1, 3, 2 3s actually. We have 1 4, 1 6, 1 6, 1 7, and 1 8. Like this, and then 1 8. Okay. Okay. So once we do this. So we need to figure out a couple of things here. So now once we do this, how can we use it to fill our buckets here? Well, we can start from the smallest numbers, right? Because we know we want to fill all the numbers in these buckets, and we know we need them to be consecutive. So let's just start from the smallest one so that it's easier for us to see if it's consecutive, because if we use the smallest one, so start from 1, then to know what number we need to pick next, it just needs to be 1 plus 1. It needs to be 2, right? And so here, what we do is we can sort this collection counter here. So basically what we do is sort this by value, right? And I already put it in a sorted order by value here, so we are good. And so we put the first element, which is 1. Okay, so now this one is done. And then for 2, we need to place all the elements of 2, right? So that we don't have to go back, right? Because we are traversing just in sorted order, we are traversing this collection. And so we put 2 here, because it's 1 plus 1 is 2, so it's consecutive, so we put 2 here. But then for the second 2, what should we do with the second 2? We can't place it here, so we place it in the second bucket, as long as it's possible to place it in the second bucket. So we place 2, and now we are done with this one. Now we look at the 3. So we can place, we can place it in the first group, because 2 plus 1 is 3. So already, what are we doing here? What are we doing just in terms of code? Well, we are going through the, let's call this occurrence here, let's call this list, this collection occurrence. So we are going through the occurrences in sorted order. So this would be in sorted order of value, so we can just say this is sorted, right? Let me just make this easier to manipulate. So we are going through the elements in sorted order, but then for each one, what are we doing? Like what we did with 2 is we go through each of the buckets and see if we can place 2 in that bucket. If we can, then we do place it. So it's sort of a greedy that way. So we go through the groups. So that means, let's say we initialize our groups first, like I did here. So we initialize it. We need the groups to have some sort of data to keep track of the elements. We can maybe have it as a list. And then we need the number of groups, which we said we calculate them. So groups count. We can calculate that by just doing groups count. It's easy to calculate by just doing the length of the hand, right, divided by the group size, and then we can just take the ceiling, right? And this is how we get from 9 divided by 3. Okay, we get that we need 3 buckets, so that's what we have here. So we go through each groups, right? So we can just say group in groups, and then if either the group is empty, or if the last element, so either it's empty, like in the case here when we place it 2, then we just place. But if it's not empty, we need to make sure we are maintaining the consecutive condition. So in that case, we need to make sure that the last element plus 1 is equal to the current element, which is v. Only in that case that we add to our current group. Now to add to the group, we just need the index, so we need to enumerate here. And we say group I, we need to add the element, right? So that's exactly basically the code of what we are doing here manually. So now we add 2, now we go to 3. We need to add 2 elements. We already added 1 here. Now where should we place the second one? Well, we just go to the next group. So 2, we check the condition. Do we have the condition basically that plus the last element plus 1 is equal to 3? Yes. 2 plus 1 is equal to 3, so we add it. So now we are done with this one. We go to the next occurrence, which is 4. Now 4, where should we place it? This one is complete, so we can't add to it. So that tells us we need to have a condition here to make sure that the length of the group is smaller than the group size, because if it's full, we can't add to it, right? So that's, we just add that condition to make sure it's not full. Okay, let me just make sure this is visible. Okay, so now we filled for 4. Now we go to 6. So we add 4 here because 3 plus 1 is equal to 4, and this one is not full yet. So we go to 6. Where should we can't place 6 here because it's full. We can't place it here because it's full. So we place it here. Now we go to 7. Again, we can't place it here. We can't place it here, but we can place it here. So we put 7. And now, same thing for 8. We can't place it in the first 2. We can place it here, however. So we put 8. And that's pretty much it. And now, how do we check if we were able to place everything correctly? We can just go through all the groups, make sure each of them has a size of group size, and if that's the case, then we are done, because we already in our construction of the groups here made sure that they are consecutive. So we don't need to check the consecutive condition because we made sure it's the case. But we need to make sure that we actually added group size elements to all of 3 groups, right? So at the end we can just check that all of them have size 3, basically size group size, okay? And that's pretty much it. So pretty simple if you think about it in terms of like what is the data structure that will allow you to get the element, and then constructing the groups beforehand, okay? Yeah, so that's pretty much it. Now let's code it up and make sure it passes. Okay, so let's take this code here. Now one thing we know is that if the length of hand, right, is not divisible by group size, then that means we can't get what we need, because let's say it's 5, the number of in the hand is 5 and group size is 3, then we can't create the groups. We know that because it needs to be a multiple of 3, okay? So we just return false in that case. Now here we just say this, and we just need to return, make sure that all of them have the right size. So I'll just make sure this is correct. Now one thing to note here that I didn't handle is this count here. For example, for the case of 2, we need to make sure we add only 2 elements, okay? But here we are adding as many groups as we have. So we need, each time that we add the value, we need to decrement the count. And once the count is 0, we should stop adding this value. So we should break. If we take a look at this one, the way we are doing it is, so for 2 here where it's 2, the way we do it is, before we add it, and then we say we have 1 2 remaining. And then once we add it here, we have 0 2 remaining. So when we get to this group, we say we have no longer any values of 2 to add, so we go to 3 in that case, right? And so that's the key idea here. And the thing that makes this work, by the way, is the fact that we are going from the smallest value to the largest, okay? And we prioritize each time the first group, then the second group. And so since the first group we added the smallest element, we have a higher chance of the next element being the consecutive one. So we won't go like input 1 here and go input 2 here, and now we don't have a consecutive elements for the first group. Doesn't make sense, okay? But since we go to the groups in the same order, that way basically we have a chance to put the consecutive element in the right group. Okay, so now we just need to check that the length of our group is equal to group size. And then we do for group in groups. Okay, and that should be it. We just make sure that all groups are full. Looks like there is a problem with this groups count. This needs to be math. This needs to be range, right? And this we need to have, of course, we need to create the counter. You can use a hash map or a counter, both work. I'll just use a counter. Okay, so sorry, we shouldn't return a list because that will not work. We need to make sure that all of them have this boolean, right? So all have the size group size. Looks like this one works, but this one doesn't, so let's just figure that out and see what's wrong. There is a typo here, different than 0, and this looks good. Yeah, because we need it to be not, if it's not divisible, then it's not possible. If it's divisible, then it's possible. So let's submit, and that works. Okay, some of this on that. Cool. Okay, so that gets accepted. Yeah, so that's pretty much it for this problem. I think it's pretty neat in two ways. The first one is you need to convert to a different data structure to be easy to manipulate this, the hand here. And then the second part is constructing the buckets. Now, if you want to use less space, you don't need to keep track of the entire list of the entire group list of elements, because look, what we are interested in for each one here is just the length and the last element. So to save space, we can just put this basically a tuple of the last element and the group count. Basically the count of elements in the group, right? And once we do that here, this would be two things, the last element and then group count. And so this would be just the last element. And this would be just looking at the group count. Okay. Same thing here. And here we just need to update it so that the last element is the value v and the group count is just incremented by 1. So this will save space because we will use only the data that we need. Let's just make sure this is last and group count. If a group count is equal to 0, and then we need to be smaller than size, this should work. Yeah, except here it's no longer the length is always 2, so we need to actually check the group count, which is in position 1, and we can submit. And this gets accepted. Okay. Yeah, so that's pretty much it for this problem. Thanks for watching and see you on the next one. Bye.